Okay, question 9 has given us two parametric equations. We've got x equals 1 minus cos t, we've got y equals sine t sine 2t, and t is a number between 0 and pi. So we're in radians this time. We've just been in degrees. We need to make sure we're in radians now. It says find the coordinates of the points, plural, where the curve meets the x-axis. So we've got these two parametric equations. The curve will meet the x-axis when y equals 0. So in other words, when sine t sine 2t is equal to 0. And that will equal 0 when either sine t is 0 or sine 2t is 0. Now if you think about it, sine 2t will be 0 more often than sine t. We're between 0 and pi, so we're looking just in this section. So if this is my sine y equals sine x graph, sine 2t will, that's terrible, will we'll do that, and we'll repeat twice as often as sine t. So when is the curve going to hit the x-axis? The curve is going to hit the x-axis anytime either sine t or sine 2t equals 0. So we're looking at three places. We're looking when sine t and sine 2t equals 0, when sine 2t equals pi over 2, sorry, when 2t equals pi over 2, when t equals pi over 2, I mean, or when t equals pi. So the three values that the curve will hit the the curve will hit the x-axis is when t is equal to 0, pi over 2, or pi. When we substitute those in for the x coordinate, because we need the x coordinates, we're going to get x is equal to 1 minus cos of 0, and cos of 0 is 1, so that's 0. Cos of pi over 2 is 0. So we're going to have 1 minus 0, which is 1. And cos of pi is minus 1. I should probably draw the cos graph. Let's draw the cos graph. So we're looking here. So when t is 0, cos of 0 is 1. So we've got 1 minus 1 is 0. When t equals pi over 2, we've got cos of pi over 2 is 0. So we've got 1 minus 0, which is 1. And then when t equals pi, cos of pi is negative 1. So we're going to have 1 minus negative 1. So we're going to have a value of 2. So the curve will touch the x-axis, will cross the x-axis at 0, 0, at 1, 0, and at 2, 0.